Hi everyone, in this video we're going to talk about how to use L'Hopital's rule. We're going to start off with an introduction, and I just want to show the form that L'Hopital's rule uses. So we're asked to take the limit as x approaches some number a of f at x over g of x, and we apply L'Hopital's rule. I like to put an LH at the top of the equal sign by taking the limit again as x approaches a, but now of the derivative of the top and the derivative of the bottom separately. So when do I know that I need to apply L'Hopital's rule is when I take my original function, and when I apply the limit, I get something like 0 over 0 or infinity over infinity, something like that. And these are called indeterminate forms. And you can get other indeterminate forms as well. For example, 0 times infinity, 1 to the power of infinity, infinity to the power of 0, infinity minus infinity, and so on. And sometimes when you have it of these kind of forms, then maybe you need to manipulate the function to get it into a fraction like this in order to solve it using L'Hopital's rule. So let's try to do some examples. So starting off with an easy example, let's say I am asked to take the limit as x approaches the number 2 of x minus 2 over x squared minus 4. Let me first try to just plug in 2. So if I plug in 2, I will get, so I like to say plug in. So if I just plug in 2, I'll get 2 minus 2 over 2 squared minus 4, which is 0 over 0. Awesome, I have one of the indeterminate forms. I know that I should probably try using L'Hopital's rule. So let me try using L'Hopital's rule now. So the limit as x approaches 2 of x minus 2 x squared minus 4. My x minus 2 is my f at x, and the derivative of just x minus 2 would be 1. Sorry, I just have to put that LH here to indicate that I'm using L'Hopital's rule. So the derivative of x minus 2 is just 1, and the derivative of x squared minus 4 is 2x. Now, let me plug in again. If I plug in now, I get 1 over 2 times 2, which is equal to 1 over 4. And so my final answer, I can say the limit as x approaches 2 of x minus 2 over x squared minus 4 is equal to 1 over 4. So now we're going to do a little bit more of a trickier example. Let's say I was asked to take the limit as x approaches 0 of x to the power of x. Now I say this is more difficult because we're not given that nice fraction where we can take the derivative of the top and the bottom right away. So let me just first of all try plugging in 0 right away. I'll get 0 to the power of 0, which is an indeterminate form. My first thought process is I need to manipulate this function somehow so I can use L'Hopital's rule. I'm going to start by bringing that x down. So let me set y equal to x to the power of x, and using ln y, I can bring that x down because of the ln rules. Now this is easier to put in a fraction form. This is the same thing as ln x over 1 over x. Okay, so now let me try taking the limit again. So limit as x approaches 0 of ln x 1 over x, and I'm going to try the plug in here. And I put quotations here since ln 0 is undefined. We're just going to get close to 0 to see what's going on. And I will get negative infinity over infinity. Again, an indeterminate form, but now we're in a format where we can use L'Hopital's rule So let's apply L'Hopital's rule then. So if we apply L'Hopital's rule, the derivative of ln x is 1 over x, and the derivative of 1 over x is negative 1 over x squared. And this is just equal to negative x. And now let me try plugging it in. I'll get 0 as my answer for ln y. But I need the answer for x to the power of x. So in other words, right now I have the limit of, as x approaches 0, of ln y is equal to 0. So that implies that the limit as x approaches 0 of e to the power of ln y is equal to the limit as x approaches 0 of y, which is equal to the limit as x approaches 0 of x to the power of x, which is equal to e to the power of 0, which is now equal to 1. And so we get our final answer as 1. So that is how you do a trickier bit of an example.